Lesson 11.6 is about arc lengths and sector areas. Okay, so here's how it works. An arc, remember, is an unbroken piece of a circle. It's an unbroken part of the circle. It's part of the circumference. So if you wanted to find out how big the arc was, first of all, you could start with the circumference, which is of the entire circle, which is 2 times pi times the radius. And you could take part of it. Okay, so you want to take the fraction of the circle that that arc represents. So what I do is I take the number of degrees of that arc, or I can measure it in here with the central angle, and that's x. If I let that, whatever number of degrees that is, if I divide that by 360, I get the portion of the circle that that arc represents. And when I multiply that by the circumference of the circle, I'm just taking a part of the circumference, and that's how I find the arc length. Now to find the sector area, remember a sector is a segment of the circle. It's like a piece of the pie, and it has area. It has space inside of it. I want to know how many square units that is. So if I start with the area of the circle, the whole circle, it's pi r squared. And I want to take a fraction of that. I want to take the part that's inside the sector. So out of the 360 degrees, it's the same thing. If I take the number of degrees that the arc or the central angle that goes with that sector represents, the fraction of that number of degrees over 360, I get the part of the circle that that sector represents. And when I multiply that by the entire area, I get the area of the sector. So those are the formulas. They both use x over 360 as number of degrees of the arc over 360 times either circumference or area of the circle. So here's how it works. Let's say I have a circle with a radius of 3 and I have an arc measure of 120 degrees, and that's also the same as the measure of the central angle in here is 120 degrees. So what I want to do is I want to find, let's say I want to find the length of the arc. So if I put this arc here in red, I want to know what's the length of that arc. So let's just say arc length is equal to, and what I'm going to do is I'm going to take the ratio of 120 to the 360, which represents the part of the circle that that arc is. We can see it's a third of the circle. And I multiply that by the circumference of the circle. So the circumference is 2 times pi times the radius. Okay, so when I'm simplifying this, 12 over 36, this is 1/3. So I get 1/3 times 6 pi, or an arc length of 6 over 3, or 2 pi units. And that should make sense. The entire circle has a circumference of 6 pi, and this is a third of it, so this is 2 pi. Okay, so now let's find sector area. So I'm going to take the circle, and I'm going to fill in the area of the entire sector here in green. And let's say I want to know that area. So sector area is going to be equal to the same fraction. So I've already got it here. I've already simplified it. It's 120 over 360. So a third of the circle times the area of the circle, which is pi times the radius squared. So pi times 3 squared. So this is 1/3 times 9 pi, or 9 over 3 pi, which is 3 pi, and this is going to be in square units. So my arc length is just in units, and my sector area is, we're talking about area, so that's 3 pi square units. Okay, in this next example, let's say that I want to find the area of that little red shaded wedge. So how could I do that? So I look at it and I notice, well, that wedge is, it's part of a sector that's been, where I've cut off part of it with a triangle. So let's describe how I might set this up. I might find the entire sector area, which looks like so, and subtract from that the area of the triangle that's inside of it. So the sector looks like so, and you've got that triangle in there, and that will leave the little wedge, okay, the little red wedge at the end. So first of all, the entire sector area. Well, let's see. Okay, so we start by finding what part of the circle does that sector represent, what fraction of the circle. So out on the side here, I can see that this is a 90-degree angle. So that means that, you know, I have a 90-degree arc out here. So I'm going to just take that ratio of 90 degrees over 360, and canceling out here, I can see that this sector is 9 over 36, or 1/4 of the circle. So my sector area is going to be 1/4 of the circle times pi times the radius squared, so times 4 squared. So simplifying that, that's 1/4 times 16 pi. So that is 4 pi. Okay, now I want to subtract the area of the rectangle, of the triangle from that. Okay, so remember that the triangle is 1/2 base times height, and it's a right triangle, so my base is 4 and my height is 4, because the radiuses are the same. So my triangle area is 1/2 base of 4 times height of 4. So it's half of 16, or 8. Okay, so the area of that wedge is 4 pi minus 8, and that's in square units, isn't it, because it's area. Okay, in this last example, again, I have to find the red shaded area. So what I'm looking at here is I'm looking at a semicircle with a triangle inscribed in it. And I think I need to find the area of the semicircle and then subtract out the area of the triangle. So one thing we need to note is that any triangle inscribed in a semicircle is a right triangle. So that's nice. If that's a right triangle, that's a 90. I have a 60-degree angle in the left corner, and I can fill in, I have a 30-degree angle in the right corner. And the radius of my triangle is 6. So let's frame what we're going to do here. I think what we're going to do is we're going to take the area of the semicircle, and we're going to subtract from it the area of the right triangle. And so if I show what that looks like, oops, my original semicircle looks like so, minus the area of the triangle, and that should leave these two kind of connected little red wedges, okay, which represents the red area. So the area of the semicircle is half of the area of the circle. So it's going to be 1/2 of pi times the radius squared. So half of pi times the radius of 6 squared. So half of 36 pi, or 18 pi. Okay, now the inscribed triangle, I want to subtract that area out. Well, what we've got here is we have, if the radius is 6, then the diameter is 12. So let's redraw that little right triangle sitting up with the right angle in the bottom left corner. The radius, or the diameter of 12, represents the hypotenuse. Okay, and the 30-degree angle, if I put that up at the top, then the short leg is 6, which is half the hypotenuse, and long leg is 6√3. Okay, so I can use the 6 as the base and the 6√3 as the height. So the area of that triangle is 1/2 base of 6 times height of 6√3. So that represents half of 36√3, so 18√3. So that would be an expression, because those are not like terms, so that expression represents the total area of the red sector, and of course that's area, so that would be in square units. And that's it for sector areas and arc lengths of circles.